Welcome back to the GHGCast, a window into the world of a Canadian company with a big idea to become the global reference for greenhouse gas emissions in the interest of reducing them. I'm Alexander Milas, and for this special quick cast, we virtually sat down with someone who's got a bird's eye view on the current challenges facing emissions monitoring, and she's also in an excellent position to tell us about what's next. And we're joined by Nicole Downey. Nicole, how are you doing? And tell us a little bit about what you do for a living.
Thanks. I'm doing well today. My name's Nicole Downey, and I am a consultant working on issues around air emissions from primarily oil and gas operations. And my company, I work for a company called Earth Systems Sciences. In fact, I'm the owner of the company. And we work primarily on the industry side of understanding where emissions originate, what the most effective methods are to measure emissions, understand emissions, reduce emissions, and report emissions.
So what are the kind of challenges that oil and gas companies face when monitoring their greenhouse gas emissions?
I think the first big challenge is the complexity of the system. You have literally hundreds of thousands of pieces of equipment in rural areas in the field, working away. Oil and gas hydrocarbons come out of the ground. They have to be separated. They have to be piped out or trucked out. And these different pieces are owned by literally thousands of companies. So even on an individual pad, you could have 3 or 4 different companies operating equipment on that pad. So it's a very complex system. I think another key issue is that routine operations in oil and gas environments include emissions from different things. Like if you need to repair a pipeline, you have to turn off the gas in that pipeline and let the pressure out so that you can work on it. And so for a little bit, you will have very high emissions at that site, but that was something that was planned. That's something you have to do. You have to do maintenance. And so it really becomes a difficult question to figure out, what did I see that I was supposed to see versus what did I see that was unexpected? Because it's really the unexpected emissions that we need to bring down and make sure we're minimizing as much as possible. And then the final challenge is, this is true for anybody trying to measure anything in the atmosphere, and that's meteorology. It is very hard to accurately quantify emission strength from downwind measurements of different gases. And that's because the atmosphere is kind of chaotic, and it's been an issue for years. Very smart people have worked on it for a long time, and there's a certain amount of uncertainty there that just can't be eliminated. So it's a difficult scientific question.
You know, it is so apparent to anyone, I think, who follows emissions monitoring that it has evolved really rapidly, especially in recent years. Now, what's driving the increased interest in tracking measurements?
I think there are several different things. First is, the companies, they don't want to have high emissions. They don't want to have excess emissions. They're extracting a product to sell, and they don't want to vent that product into the atmosphere, right? But then I think on top of that, there's intense regulatory pressure here in the United States, in the European Union, in Canada. All governments are looking to reduce greenhouse gas emissions, and methane has a high global warming potential, so it's an attractive candidate to mitigate warming in the short term. So there's very intense regulatory pressure. And then finally, I don't think it can be understated how important shareholder pressure and public pressure has been to get companies to really think about their emissions and minimizing their emissions as much as possible.
So it's interesting because it sounds like it's not just a development on the industry side, it's also a social and a cultural dimension to it all as well. So what is the state of the art? I mean, how are companies currently measuring emissions? And I mean, are there limitations to what we're able to see and detect?
Yeah, so in the past and historically, companies and regulatory agencies have really relied on what's known as bottom-up or engineering-based estimates. And that's where you count up the number of components in the field and you understand what they do because you built them, and you estimate your emissions that way. But then over the past several years, there's been a lot of new technology developed that take a more off-site approach. It's called more of a top-down approach, where you measure concentrations of greenhouse gases in the air and then invert for the emissions. And so right now, I think companies are, they're still using the bottom-up engineering-based approach, but they're trying to figure out what are the best technologies to supplement that. And what works the best for my operations. And that's a key issue, is that different companies operate in different ways. Different segments of the industry operate in different ways. And so the different kinds of technology that work are different in different areas. So, there are people developing ground-based sensors, putting networks of small sensors all over a pad, a well pad, for example, and looking for methane. There are people developing mobile sensors where you drive a car around and look for emissions. People have used infrared cameras on site for quite a long time, and that is, in fact, a regulatory standard right now. People are developing drones that can carry different instrumentation around sites to look at what emissions look like. And then there are several groups developing aircraft-based platforms that can fly over entire fields. And then finally, there are groups like GHGCast measuring methane from satellites, so that they can see, from a wide view, what's going on from space.
So it sounds like an incredibly wide array of approaches to the same problem. So how do you envision all of these different ways of detecting methane emissions integrating and working together?
I think it's going to be a very interesting evolution, and I don't know what combination of technologies will ultimately be successful, and I think it will be different for different segments of the supply chain. I really think there will be a combination of engineering-based understanding and estimates of emissions, and then remote measurements of methane in different ways. And I think the way to think about it is you have your inventory-based emissions, you have what you think you know, and it's very difficult to quantify your emissions from the air, right? It's just a difficult scientific problem, but it's not as difficult to find problems, to find high emission events that you can likely fix. And so I think what will probably shake out as being a good solution is to have, what your inventory thinks component by component, but then on top of that, some monitoring for upset conditions that are not planned, that are not what you think should have been there. And minimizing those emissions can really help companies to reduce their overall emissions and bring them, down to the level of emissions that they hope to achieve.
It's an exciting time, certainly, and it feels like we are in a pivotal moment, certainly, for the industry. So looking to the future, how do you see these technologies evolving?
I think it's going to be quite a lot of trial and error. I think we're right in the middle of this right now. People are deploying different technologies. Startups are in the field experimenting with different companies. And we'll see some technologies break out for specific use cases. And I really anticipate that a variety of tools will be developed that are successful. And I think that will include a variety of, modeling of analytics, understanding what is happening in the field from an inventory perspective, but then also sort of the top-down approach where you're measuring at different spatial scales with different instrumentation to make sure that you understand exactly what's going on. And so I think, it's going to be really exciting. There's a lot going on in this field right now, and it's a time of rapid technology development.
Well, exciting is definitely the word for it, Nicole, and we're so appreciative of your taking the time to help us parse it out just a little more. Thank you so much for your time, and good luck with all things.
Thank you very much.
This has been a GHGSat Quickcast. We've many more stories to tell, so subscribe to us at ghgsat.com or where all fine podcasts are found. And big thanks to John Mitchell and Lonely Robot for the music.